Bismillah Rahman Rahim. Today we will start one of the very important topic in database management systems, and that topic is actually the concept of normalization. The chapter is 14, and the title of the chapter is The Basics of Functional Dependencies and Normalization for Relational Databases. So, that is our chapter for today, and we will start our discussion. The chapter outline, that is also very important to know that what we are going to discuss. So, the first point is that informal design guidelines for relational databases. There we will discuss number one, that what are the semantics of the relation attributes, because as we know that a relation is itself a table, and table consists of attributes. So we will see in this topic that what are the semantics of those attributes, and we will try to see the relationships and meanings of those attributes within that relation or a table. Then 1.2 is regarding the redundant information in tuples and update anomalies. So we will see that wherever we have that redundancy in those tuples or records within that relation, that we have to consider what type of redundancies are possible, and of course how we will apply the update concept, or the how we can remove the update anomaly. When I say an update anomaly, it means that whenever you go for an update or a change, or let's suppose in a value of a particular attribute, then how it affects the relation and all other relations which are related to that particular relation. So in now 1.3 is the concept of null values. As we have discussed in the properties of the relation, that relation can hold null values, but we have to be very careful while we allow those attributes to have those null values, because in this topic and the other topics we will follow after this, there we will see that whenever we allow those null values, we have to be careful while we applying various operations on those relations, because if a value there is null in one record and we want to make a relationship with the other record in the other relation, so all those relations will come out to be null. And we'll talk about superior tuples, all those tuples which have been generated whenever those operations will be applied, and that those we have to identify those superior tuples, and we have to remove those superior tuples as well. And number two topic which is there in this chapter, which is very important, is regarding functional dependency, and we will discuss in detail what functional dependency is. In short, the functional dependency is a relationship which exists among the attributes. Let's suppose a table have 5 attributes. So functional dependency is normally observed among the attributes. Let's suppose whether the employee number determines the employee name, or the employee grade determines the salary, or the address determines the city, so on and so forth. So these are all called functional dependencies. So in this chapter, we will see the definition of functional dependency, and we will see practically that how we can identify those relationships among attributes in a given relation. So number third point which we will discuss in this chapter is regarding the normal forms based on the concept of primary key. So there are various kinds of normal forms which are there when we talk about normalization. So we'll talk about the normalization in this presentation, and we will see how we can define various normal forms. Normally, these normal forms are defined as first normal form, then we call it the second normal form, then we will see the third one, and then BCNF or fourth normal form, and so on and so forth. These are various kinds of normal forms. So we will discuss one by one with examples and see that how those normal forms can be applied on various relations to normalize those relations. So that is the outline of this chapter, along with last these two topics, the concept of fourth normal form, where we have multi-value dependency, and number 7, the last point is the joint dependencies, which we'll discuss in this chapter. So we'll start with the first topic, and the first topic is regarding the information design guidelines for relational database. These guidelines are very important because if we have those guidelines, if we have a good understanding of those guidelines, then in future we'll never have a problem in our relational model. So that is actually a normalization itself is a concept, and of course it's a process as well to apply on those relations. So if you will able to understand that concept in this presentation, then I believe that you will never forget that principle whenever you are building relational models. So what is a relational database design? Number one, uh, so how we can say what is a design? The grouping of attributes to form good relation schemas. So what the design itself means, that how you identify various attributes within the relations and how you group those attributes into various relations. For example, in this chapter, we are talking about a company database where we have various relations, and we have seen the schema as well. That company database example we will also go through in this chapter as well. And if you just recall the company database, you remember that there was an employee relation, a department relation, the project relation, dependent relation, so on and so forth. So these are all various relations which is there in the company database. But let's take any other example as well. Let's suppose you take example of the university database as well. So I just so we first discuss the informal guidelines for a good relation, and then we discuss the formal concepts of functional dependencies and normal forms. As we have discussed earlier on, that we have various normal forms as first normal form, second, third, BCNF, fourth normal form, so on and so forth. And we will see the various types of dependencies which exist among the attributes. So whenever we apply the process of normalization, actually that improves your design of the database. It improves your design of the schema. And when I say that you identify what groups are essential within that relation, it means that you must know which attributes will come in the employee relation, which attributes are necessary for a dependent relation, which attributes are important in a project relation in terms of the schema. So that is basically the design process. So here we will move forward and we will see the guideline number 1. Now you'll try to remember those guidelines. First guideline number 1: informally, each tuple in a relation should represent one entity or a relationship instance. Of course, let's suppose take an example of an employee table. So in an employee table, let's suppose we have 56 records. So these 56 records means 56 tuples, and 56 tuples means that if you consider each tuple, that each tuple itself is an instance, one instance that considered to be the one instance, and in other words, normally we call it one entity as well. So employee itself is a group of various instances which are employees. Let's suppose there are 56 employees, so there will be 56 records. So attributes of different entities, let's suppose we talk about employee table, we talk about department table, we talk about project table, should not be mixed in the same relation. That is the basic principle. That what mistake we can do earlier on is that we can put all the attributes in the same relation, which is not required. This is let's suppose I just show. So let's take an example. The first guideline is do not mix the attributes of various relations into one relation. Let's assume that we have the employee relation where we have the EMPNO. Let's suppose the employee number. Let's suppose the EMP name. Let's suppose we have the contact. I just pick few attributes just to give you the concept. Employee name, the contact, let's suppose the designation. Let's assume any other attribute as well. Uh, so let's take another attributes: employee number, employee name, contact, designation. Let's suppose salary. Let's suppose take one more attribute. For instance, the phone contact, phone. That is, let's suppose these are the attributes. Just for example, I want to have for an employee. Okay, and I have another entity as well. I have another relation as well. For example, that relation is department, and department relation is, let's suppose, department number, department name. So if you want to put the same information of all the attributes of the department table, if you want to put this in, let's suppose, mix this with this table, let's suppose department number, department name, and let's suppose, and take another attribute, that is location. Okay, so what I did, I combined these attributes in one relation. So normalization is a process where you do not have to mix all those attributes. And let's suppose if you try to mix with project, so project number, project title, title, and let's suppose project head. So I put all these attributes in one relation. So if I put all these attributes in one relation, then it means that there will be redundancy. You can see yourself the data will become redundant. How data will become redundant, you can see over here. I can let's just take for example 101 is an employee whose employee name is Ali, whose contact is 3219 3216, whose designation is clerk, and whose salary is 20, let's suppose 20K. His phone is 98765. His department number is 10. His department name is, let's suppose, the finance. Let's suppose the location is Karachi. Project number is, let's suppose, 101. Project title is, for example, XYZ, and the project head is, uh, let's suppose the project head is 107. I just write the code, and now we have various employees. Let's suppose we have another employee as well whose number is 102, Ahmed. Let's suppose he also works in department number 10, and if he works in the department number 10, the same information will come here, the same information will come here, and let's assume he works in the same project, so the same information will come here as well. So you can see yourself. Now what is redundancy? You can see if we have more employees and if they have similar departments, that information will be repeated. Similarly, if they work in the similar projects, that information will always be repeated. So let's suppose if we have 100 employees, 200 employees, so in many rows, in many columns, you can observe the data is redundant. So why it is redundant? In this case, because we have combined the various group of attributes into one table. So that is the first guideline we have. The first guideline says that the attributes of different entities should not be
Yeah.
mixed in the same relation.
So it
In
is
other words, we can say,
yeah.
in other words, we can say
What you
that
more
the various various themes can be represented in various relations. So you can say that department is a separate theme. So that department has to be represented in a separate relation. Project is a separate theme that has to be represented in a separate relation. The dependent is a separate theme that has to be represented in a separate relation. So it whenever we have different relations, we use what? We use foreign key. So here you can see that only foreign keys should be used to refer other entities. So when we have various relations, then we have to build the relationships. And whenever we have to build the relationships, we need to have a referential integrity constraint. And that referential integrity constraints are only enforced through the foreign key. The entity and relationship attribute should be kept apart as much as possible, and the relation attribute should be kept apart. We have to put it in that table. The bottom line is what? Design a schema that can be explained easily relation by relation rather than mixing all the group of attributes into one relation. That is the first guideline we have. Now we'll move towards the second guideline. Before moving toward the second guideline, here you can say the same company relation, and that company relation, the same relation which, so same schema which we take for all examples in this book. So here you can see that you have an employee relation which is actually has a relationship with the department. So that has a foreign key as well. Department has a relationship with locations. Project has a relationship with department and also with the employee. And there is a relation which is works on. That is a relationship between project and employee. And there we have a separate relation. And you can see yourself that various primary keys and foreign keys are there. And that is the definition of the schema of the company database. So keep this example in your mind so that you can understand those concepts. Now we will move forward to see the second guideline. The second guideline is that redundant information in tuples and update anomalies, as I have just showed you with example, that there can be a redundant data. Redundancy cause serious problems if you have not identified carefully within the schema, because if there is a redundancy, it always leads to inconsistency. And if there is inconsistency in your model or in your application, that it means that that application or your model itself is not reliable. So we need to remove those redundancies. uh, Whenever we store that redundant information, first thing which happens is very simple, that we have wastage of storage. So we are keeping that data again and again with ourselves. So whenever we are keeping that data again and again with ourselves, what will happen? Of course, we will consume more memory. There is no need to record that data, but we are recording it repeatedly. So first problem that it will cause is that it will waste the storage. The second problem or problems that might arise whenever you have redundant data, there are three kinds of anomalies. What is an anomaly? Simply, we can say that anomaly is something which is, you can say it itself is a problem, or you can say it is something which might create issues in your schema, or anomaly is something which has to be removed. So before removing an anomaly, those anomalies have to be identified first. So how you identify those anomalies? You can identify those anomalies in three ways. Either that anomaly is an insertion anomaly, either that anomaly is a deletion anomaly, or that anomaly is a modification anomaly. I just want to represent these facts with an example, with a demonstration. Let's see this table which I have just formed. So I just, for the sake of the anomalies, I want to extend this table further, and I will add some further information here so that you can realize that how these anomalies can work. So here I can put some more data just to show you how those anomalies can be identified. So I just put some hypothetical data just to give you the concept. For that purpose, I need to put some records so that you can identify the concept. So I will put 6 records at least so that you can understand the concept. So I just copy that data and then I can change it accordingly. So I can change the data now. Let's suppose uh, this is, I change the value, and let's suppose that is 2213. That is that is the database expert. His salary is, let's assume, 35K. His address is 6543. His department number is, let's suppose, 30. And that department is, let's suppose, database is Karachi. He's working on the project 103. That project is DFD, and it is heading by 103. I just put some hypothetical data over here so that you can realize that how it works. Let's suppose I put one more entry over here, that is 6754, and that is, let's suppose, the front end developer. His salary is 24K, and the contact is 7654. Is a phone number, and let's assume that also works in 30. The department number is again database, and the location is in Karachi, and that also works in 103. Okay, that works in 102, no problem. That data can be same. Okay, no issue. And here, let's only change this value, and then we can see how it will work. Let's suppose that is Kashif, and his number is this, and he is, let's assume, the SQA, and his salary is, let's suppose, 35K, and his contact is 44 times 8, and let's suppose he works in department number 40, and that department is a new department. So let's suppose that that department is a quality department that is in Lahore. Okay, and that works in 10, let's suppose 4, and that should be different. So y, and that is being had by, let's suppose, 109. Now let's see this. I just put some data, and here I can also add some values so that you can understand. So here we can put some values. Let's suppose that Ahmed works as the typist and his salary is 10K, is 8889, and let's suppose he works in department number 10. Okay, fine. Now that data is complete for your purpose. So what is insertion anomaly? Let's suppose I want to add the data of another employee, and that employee will work in a department which is not mentioned over here. Let's suppose that department is department number 50, and that department is logistics. So I want to enter a data of an employee who will work in logistics. So remember, I want to insert a fact, that is the information regarding an employee, but I cannot add this information until I have that information about the department and the project. So that is called as insertion anomaly, because I cannot enter that fact, because if I enter that fact, I have to enter the department information as well, and as well as the project information. So that is called insertion anomaly. Means if you want to insert a fact about a particular employee in a given relation, and you have to enter the information of the other fact as well. So in this table we have actually three facts, so I will just change the color so that you can understand. So I just want those colors where you can. The next theme here is this one, so I just change the color so that you can realize, and that is another theme. So actually we have three themes which are here. One is called the one is called the what? One is called the employee. That is one theme, that is in yellow. Same color, different color is here for department, different. So inserting a one fact force you to enter another fact. That is called insertion anomaly. Now let's take the example of deletion anomaly. So when you have an example of a deletion anomaly, let's see what is the problem we have. Let's suppose I want to delete this fact, that I want to delete that employee. That employee is what? That employee is Hassan. So if I want to delete that fact, that employee Hassan, that fact will also be deleted because it is in the same table. That is department number 20. That fact will also be deleted. If that fact will also be deleted, so the 20 is not there in this table in any other record. So it means what happens, that if I delete one record, or if I delete a fact, sorry, not a record, if I delete a one fact or a one theme, the other fact will also be deleted. That is called deletion anomaly. And what is an update anomaly? Update anomaly is when want to change something. For example, let's take these two employees works for department number 30. So let's assume that in department number 30, the location is now changed. It is not Karachi, it is now Hyderabad. So so all those relation, wherever we have that reference number 30 department, or department number 30 is there, those location has to be changed. So change in one record will force you, or change in one fact will force you to change all other facts. But in that case, this is not happening, because changing a one fact here will not help us to change. So we cannot change it over here. So that cannot be changed. So that is called update anomaly. So there are three kinds of anomalies. Those anomalies are called insertion anomaly, deletion anomaly, and the update anomaly.